Hello and welcome back to this channel. Dear students, this topic is Y parameters. I will explain you how to solve numericals related to Y parameters. इससे पहले मैंने इसके डेरिवेशन का वीडियो बनाया है. Please watch that video so that all the concepts will be more clear. Now these are the reference equations of Y parameters. We know that Y is admittance. So first equation is I1 is Y11 V1 plus Y12 V2. Second equation is y21 v1 plus y22 v2. As I said, these are the reference equations. We need it while solving the numericals. Now given question is find y parameters of the following network. This is the given network. Actually it is called T type of network because its shape is like English letter T. The values are 200 ohm, 200 ohm and 400 ohm. अब देखो जो रेडिंग से मैंने लिखा है मार्क किया है दैट इज दिस करंट I1 दिस करंट I2 दिस डायरेक्शंस आर फिक्स्ड बोथ करंट्स आर मूविंग टुवर्ड्स दिस नेटवर्क सो I1 is incoming I2 is incoming voltage at input side is V1 voltage at output side is V2 through this branch no standard notation is there so I have considered this current as I3 and I have assumed this direction as a downward direction by default this bottom line is connected to ground do remember इससे पहले का जो डायग्राम था दैट डायग्राम वुड हैव बीन गिवन इन द एग्जाम ये जो रीडिंग से मैंने बनाया दैट यू विल नीड टू राइट द नोटेशन इन द डायग्राम नाउ रिमेंबर इट लाइक दिस फॉर y पैरामीटर यूज KCL दैट इज किरचॉफ्स करंट लॉ और नोड एनालिसिस इट विल मेक द कैलकुलेशंस इजी सो अकॉर्डिंग टू नोड एनालिसिस एट एनी नोड ये जो नोड है दिस इज वन नोड whose voltage I have denoted it by VA. Again this VA is not given in the question. So we need to add this notation that is node voltage VA. By default this terminal is grounded. According to KCL, at any junction or at any node, summation of incoming currents is equals to summation of outgoing currents. Look at the diagram. I1 and I2 are moving towards terminal VA. So I will write this as incoming currents that means equation will be I1 plus I2 is equals to outgoing current from this node is current I3 so it becomes I1 plus I2 is equals to I3. Now we have to write every current in terms of voltage. Recall the basics. अगर कोई resistance ऐसा है say this is R at one end voltage is V1 at another end voltage is V2 and this current is I. We know the procedure. If current I is moving from LHS to RHS that means from V1 to V2 then this equation is V1 minus V2 upon R. Same logic I am using. So for I1 I can write the equation as I1 at one end we have voltage VA V1 at another end we have voltage VA and current is moving from V1 to VA so it is V1 minus VA upon value of resistance that is 200 ohm plus I2. Equation of I2 same way at one end we have V2 at another end we have VA so it is V2 minus VA upon 200 equals to for I3 at one end voltage is VA it is moving from VA to ground so it is VA minus 0 upon 400. To make the thing simple, calculation easy करने के लिए ऐसा हैबिट लगा लो. It is V1 by 200 means it can be written as 1 by 200 into V1 minus 1 by 200 into VA. Likewise, we can write every term. So, if you write it like this, 1 by 200 into V1, so this value will be 0.005 V1. Then minus 1 by 200 into V1 again minus 0.005 VA plus 1 by 200 into V2 0.005 V2 minus 1 by 200 into VA minus 0.005 VA is equals to 1 by 400 into VA that is 0.0025 into VA. Now how to think? We have to obtain equation of VA. Why we need equation of VA? Look at the reference equations. These are reference equations of Y parameter. Equation must contain current and voltages. That is, look at equation of I1. It has I1, V1 and V2. Similarly, equation of second equation I2, V1 and V2. There is no term related to VA. So I need to obtain equation of VA in terms of V1 and V2. So let us combine the terms. अब देखो ये VA का एक टर्म है, ये दूसरा टर्म है, this is third term. So combine the terms. So minus 0.005, then minus 0.005, and if you transfer this at the LHS, it becomes minus 0.025. So this can be written as minus 0.005 VA minus 0.005 VA. Second term I consider. If I will transfer this at the LHS, it becomes minus 0.0025 VA is equals to transfer V1 and V2 terms at the RHS, so it becomes minus 0.005 V1. ये टर्म प्लस है, ट्रांसफर करने के बाद माइनस हो जाएगा. सेम वे दिस टर्म अगेन बिकम्स माइनस 0.005 V2. Now if you add all these terms, so you can write it like this: VA in the bracket minus 0.005 minus 0.005 minus 0.0025 is equals to this RHS remains same, 0.005 V1 minus 0.005 V2. Simple technique, we want equation of VA, so I will transfer this term at the RHS. That means it will be minus 0.005 divided by this entire term into V1. Same thing is applicable for V2. So if you solve this, then you will be getting equation of VA is equals to 0.4 V1 minus 0.4 V2. We have got, this is plus 0.4 V2. We have got the equation of VA in terms of V1 and V2. Say it is equation number 1. What we need to do? We have obtained equation of VA in terms of V1 and V2. Now we want equation of I1. Refer this equation. This is the equation of I1. I1 is V1 minus VA upon 200. So put the value in the equation of I1, that is in this equation. So V1 minus 0.4 V1 minus 0.4 V2. Observe carefully, it is V1 minus VA. This is equation of VA, equation number 1. So it becomes minus minus divided by 200. This is the equation of V1. Like the earlier case, again what you need to do? 1 by 200 into V1 minus 0.4 upon 200 into V1 minus 0.4 upon 200 into V2. So if you simplify this, you will get equation of I1 as 0.003 V1, 0.003 V1. Second term will be minus 0.002 V2. Say equation number 2. Now remaining part is pretty simple. We have got equation of I1 in terms of V1 and V2. Compare this equation with equation A. So here coefficient of V1 is Y11. Here coefficient of V1 is 0.003. So directly we can write Y11 is equals to 0.003. Y is admittance. It is reciprocal of impedance. We know that notation or unit of impedance is ohm. So unit of admittance is mho. So this is one parameter, Y11. Same way, look at the second coefficient, it is minus 0.002. And look at the equation, this equation 2, I need to compare with equation A again. Here with V2 we have Y12. So this term gives value of Y12. So Y12 is equals to minus 0.002. That means comparing this equation 2 with equation A, we have got two values Y11 and Y12. अब देखो यहाँ पे मैंने सेपरेट आंसर लिख के रखा है फॉर Y11 एंड Y12. सेम टेक्निक वी हैव टू use for calculation of current I2. First we have to obtain equation of I2. Look at these equations. For I2 we have the term V2 minus VA upon 200. Same way we have to put the values, we have to put the value of VA over here. So equation of I2 is V2 minus VA upon 200. Let us put the values. So it is V2 minus VA. We already discussed value of VA is 0.4 V1, then minus plus 0.4 V2. This minus sign is taken outside. So V2 minus VA is this equation 0.4 V1 plus 0.4 V2. So if you transfer this minus sign inside the bracket, both the terms will be negative upon 200. This is equation of I2. Make it simple. It can be written as 1 by 200 V2. This V2 upon 200 is 1 by 200 V2 minus 0.4 V1 upon 200, that is 0.4 upon 200 V1 plus this again becomes minus because we have taken minus sign outside the bracket. So minus 0.4 upon 200 into V2. You need to simplify it. You need to club these two values of V2. This is basically equation of I2. So after simplification, I can write this first term is 0.4 upon 200. So it is minus 0.002 V1. I am talking about this term V1, which is 0.4 upon 200. If you combine these two terms, 1 by 200 V2 minus 0.4 upon 200 V2. So this gives me value of minus plus 0.003 V2. This is the equation of I2 in terms of V1 and V2. So this I got after solving these two. So it is 1 minus 0.6 upon 200. So final answer is 0.003 V2. Say equation number 3. Again compare this equation with equation B. Equation B is equation of I2 in terms of V1 and V2. So first coefficient, like the earlier case, is Y21 with V1. With V1 we have this term. So I will write Y21 is equals to minus 0.002. Unit is mho. This is the value of Y21. Same way, look at this second term. It is Y22. यहाँ पे term है 0.003. Therefore Y22 is equals to 0.003 mho. So these are the answers of Y parameter. The next numerical is find Y parameter of the following network. This is the given network. In the question itself, it is mentioned this current is I1. At the output, this current is I2. 5 ohm resistance, 20 ohm resistance and 15 ohm resistance. This is basically called pi type of network. If it is a pi network, we have a ready-made formula, but we'll solve the numerical using normal method, and then for checking we'll be making use of this formula. So to proceed, we need to add few more notations in the given diagram. As I said, this current is I1, which is mentioned in the question. This current is I2, which is again mentioned. We know that this voltage is input voltage, which is V1. At the output, we will mark voltage V2. Then in only these two branches, currents I1 and I2 are shown. We need to assume the currents in other branches also. Let us say this is I3, this current is I4, this current is I5. We know that we have to apply KCL, so name and directions are immaterial as far as current flowing through 5 ohm is concerned. Now there are two nodes. One is this node. This node will denote it by V1. Question arises why? Why not VA or VC or any other name? Very simple logic. At this point we are applying V1. This is the wire, that means this is the branch and no resistance is there from this point to V1. So this voltage, which is V1, will be same as this node voltage V1. Same logic is applicable for V2. इस point का voltage V2 है, यहाँ पे बीच में कोई भी resistance नहीं है. So this point's voltage is again V2. So we have marked the notations and directions in the given diagram. Now let us apply KCL at both the nodes. So first at node V1, we know the basic rule of KCL, summation of incoming currents is equals to outgoing currents. At V1, incoming current is I1, outgoing currents are I3 and I5. So corresponding equation will be I1 is equals to I3 plus I5. This current is I1, which is incoming at node V1, I3 and I5 are outgoing nodes. Then we need to express each current in terms of voltage, but do remember this is equation of I1. We have to compare it with reference equation A. At LHS we have term I1, so we will keep this I1 as it is. We won't convert it in terms of voltage. So I am keeping LHS as it is, that is I1 equals to I3, look at the diagram. At one end voltage is V1, another end is grounded. So it is V1 minus 0. That means V1 upon 15. This is equation of I3. Then about I5. I5 is the current flowing from V1 to V2 and corresponding resistance is 5 ohm. So it can be written as V1 minus V2 upon 15 ohm. So this is the equation. This is not 15, this is 5 ohm. So it is 5 ohm. This is the equation we need to simplify it. So it can be written as 1 by 15 V1 plus 1 by 5 V1 minus 1 by 5 V2. Therefore, equation of I1 after simplification, you may well convert it in terms of decibels by using decimal point by using calci, but you can well solve it like this by taking LCM and so on. So these two terms can be combined. LCM will be 15. So it is 4 by 15 V1 minus 1 by 5 V2. Say equation number 1. Now compare equation 1 with reference equation A. So in this case, notation or coefficients of V1 corresponding to V1 is Y11. Here multiplying term with V1 is 4 by 15. Therefore, I can write Y11 is equals to 4 by 15. This is admittance. So notation is ohm. This is one parameter. Same way, compare second term of equation 1 with second term of equation A. So we can write Y12 is equals to minus 1 by 5 mho. This is the second equation. Now we have applied KCL at V1. Same technique, apply KCL at V2. So apply KCL at V2. If you apply KCL, look at the diagram. Incoming current is I2 and I5. So I will write it like this. I2 plus I5 is equals to I4. Therefore, I2 is equals to I4 minus I5. Like the previous case, we will keep I2 at the LHS as it is because we have to compare it with equation B. So I will write the next equation as I2, I am keeping it as it is equals to I4. Look at the diagram. Equation of I4 is V2 minus ground level, that is V2 minus 0 upon 20. So it is V2 minus 0 upon 20. That is V2 upon 20. This is equation of I4. I5 is current flowing through this 5 ohm resistance. So it is, this is minus sign, it is I4 minus I5. So it is V1 minus V2 upon 5 ohm. So this can be written as 1 by 20 V2 minus 1 by 5 V1. This minus minus become plus 1 by 5 V2. We need to simplify this equation. So I2 can be written as I2 is equals to, first I will write term related with V1. So it is 1 by 5 V1. Then let us combine these two terms. So this is 1 by 20 plus 1 by 5. So it will be, LCM will be 20. So I am talking about these two terms. LCM will be 20. In the numerator we will be having 1 plus 4. That is 5 by 20. So 5 by 20 is 1 by 4. So it is plus 1 by 4 V2. This is the equation of I2. Again, compare this equation with reference equation B. First term is Y21. Here first term is minus 1 by 5. So I will write the answer over here. Therefore, Y21 is equals to minus 1 by 5 mho. Then second term in equation B is Y22. So Y22 is equals to, this is Y22, corresponding term in this equation. Let us say this is equation number 2. We are comparing equation 2 with equation B. So this corresponding term is 1 by 4. So it is 1 by 4 mho. These are the values of Y21 and Y22. अब जैसे मैंने बताया हम लोगों को आंसर क्रॉस चेक करना है. I have written the rules. Y1 is summation. This sign indicates summation. Summation of admittance at node 1. Do remember admittance is reciprocal of impedance. Node 1 पे कौन कौन से admittance connect किए? एक one admittance, one impedance is 15, another impedance is 5. Look at the rule. Summation of admittance connected at node 1. So I will write it over here. So it is 1 upon 15 plus 1 upon 5, because these two resistors are connected to node 1. So I have to take reciprocal of this 1 by 15 plus 1 by 5. Again, if you take LCM, then it will be 4 by 15 more. Second, Y22 is equals to summation of admittance connected at node 2. At node 2, we have 5 ohm and 20 ohm. So it is, again, take the reciprocal 1 by 5 plus 1 by 20. So LCM will be 20, and it is this LCM is 20, and this is 4 plus 1, that is 5 by 20. 5 by 20 is again 1 by 4. So Y21 is 1 by 4 more. Then Y12 is equals to Y21 is, look at the rule, minus common admittance between node 1 and 2. Between node 1 and 2, we have 5 ohm, its admittance is 1 by 5, and rule is minus of this thing. So it is minus 1 by 5 more. So check the answers. Y12 is minus 1 by 5, Y21 is minus 1 by 5, Y22 1 by 4 ohm, then Y11 4 by 15 ohm. So this is the way how to cross check the answer using direct method. Next numerical, find Y parameters of the following network. This is the given network. Note that this is not T or pi network, but we have to calculate Y parameters. That means we will be using KCL. These are the reference equations of Y parameters. Now, before starting the calculations, let us mark the notations and different directions of current. We know that this point's voltage is V1. There is 1 ohm resistance between this point and V1. So we cannot say this point's voltage is V1. Let us assume some different notation, say V3. This point voltage is V2, which is marked in the question. This point is same as this one because there is no resistance in between. So voltage at this node is V2. Let us mark different currents. We know that at input, this current is I1. Then at output, from output side, this current is I2. For different branches, mark current, say I3, I4 and I5. As we discussed earlier, the notations are immaterial. You can well make use of any other notations, as well as directions are also immaterial. Now let us apply KCL at node V3. So at V3, we know the rule. KCL means summation of incoming currents at that node is equals to summation of outgoing currents. At V3, incoming current is I1, outgoing currents are I3 and I4. So I can write I1 is equals to I3 plus I4. Now, this current I1 can be written as V1 minus V3 upon 1. So I will write it like this, V1 minus V3 upon 1 is equals to I3. This resistance is 2 ohm. I3 is current passing through 2 ohm. So it is V3 minus 0 upon 2. That is V3 upon 2 plus I4. I4 is current passing through 2 ohm from V3 to V2. So it can be written as V3 minus V2 upon 2. Let us simplify the equation. So I can simply write it as V1 minus V3 is equals to, if you take LCM, this denominator is same. So it is V3 plus V3 minus V2. This 2 can be transferred at the LHS. So I can write it like this, 2V1 minus 2V3 is equals to, these two terms can be combined. So it becomes V3 plus V3, that means 2V3 minus V2. We have already transferred this 2 at the LHS side. What is our aim? We have to obtain equation of V3 in terms of V1 and V2. So this term V3 will be transferred at the LHS. Already there is minus 2V3. This becomes minus. So it becomes minus 4V3. This V1 I will transfer it at RHS is equals to minus 2V1 minus V2. Now both sides we have negative sign. So entire term can be written with plus sign. Now equation of V3 can be written as, this is 2V1 upon 4 plus V2 upon 4. Therefore V3 is equals to V1 by 2 plus V2 by 4. Say equation number 1. This is the equation of V3 in terms of V1 and V2. Now what is our aim? We have to obtain equation of I1 that should contain V1 and V2. Look at the equation of I1. This is the equation of I1. So I1 can be written as this term I am referring V1 minus V3. V1 minus V3. Let us put the value of V3 over here. So it can be written as V1 minus V1 by 2 minus V2 by 4. It is V1 minus V3. So V1 is kept as it is. This becomes minus V1 by 2 minus V2 by 4. Therefore, I2 can be written as this. These two terms can be clubbed together. So it is V1 by 2 minus V2 by 4. Say equation number 2. Now compare this equation 2 with reference equation A. Here term is y11, so I can directly write the answer of y11 as y11 is equals to coefficient of v1, that is 1 by 2, so y11 is 1 by 2 more. Second parameter, this term is minus 1 by 4 and this coefficient is y12, so I can write y12 is equals to minus 1 by 4 more. These are the answers of first two y parameters. Let us apply KCL at another node, that is V2. So at V2, we can apply KCL like this. Incoming currents are I4 and I2. Outgoing currents for V2 are I5. So I can write it like this. I2 plus I4 is equals to I5. I want equation of I2. Therefore, I2 is equals to minus I4 plus I5. Very simple. This I4 is transferred at the RHS side. Keep I2 as it is equals to minus. Look at the diagram. I4 is current flowing from V3 to V2. So it can be written as V3 minus V2 upon 2 plus I5. I5 is current flowing through 4 ohm resistance. At one end voltage is V2, another end is grounded, so it is V2 minus 0 upon 4. So simply I will write V2 upon 4. Therefore I2 can be written as minus V3 upon 2. This minus minus become plus V2 by 2 plus V2 by 4. These two terms can be combined together. Therefore I2 can be written as minus V3 upon 2. So if I will combine these two terms, यहाँ पे लिखता हूँ मैं, LCM will be 4 and this will be 2V2. This is 2V2 plus V2. So it becomes plus 3V2 by 4. But V3 is unwanted term. We want to express in terms of V1 and V2. So put equation 1 in this equation. That is, put the value of V3 over here. Therefore, I2 can be written as this minus 1/2 inside the bracket V1 by 2 plus V2 by 4 plus 3V2 by 4. Therefore, I2 becomes minus 1 by 4 V1 minus 1 by 8 V2 plus 3 by 4 V2. These two terms can be combined by taking LCM. So LCM will be 8. This is minus 1 plus this is 3 by 4. LCM is 8, so it becomes plus 6 into V2. Therefore, I2 can be written as minus 1 by 4 V1 plus 5 by 8 V2. Say equation number 2. Now compare this equation with equation B. We have Y21 over here. This term is minus 1 by 4. Therefore, I can write Y21 is minus 1 by 4 more. This is answer of Y21. Next term with V2, we have Y22. Here we have 5 by 8. Therefore, Y22 is equals to 5 by 8 more. So, using simple KCL, we can calculate Y parameter of any given network. So, dear students, that's it for today's session. So, thank you. Thanks a lot for watching this video.